BrainAnalyst is a neuroimaging software which can process MR diffusion, perfusion, fabric tracking, activation, VBM and connectomics, and runs on macOS, Windows and Linux OSs. I implemented it on the AW Workstation in two ways, either in a fully automated black box way, the user doesn't have to interact with the software to get the results of the processings, or in an end-user way, the user can fully interact with the software. So to see how it's working, let's have a look at some practical cases. First case, brain tumor, glioblastoma. Main issue with brain tumors is to be able to differentiate between edema and tumor cells involvement. In this specific case, MR diffusion, especially multi-compartmental or multi-B diffusion, can help. But what is multi-B diffusion? In homogeneous environment, signal decay of diffusion is quite simple, but in heterogeneous environment, signal decay is more complex and reflects the different compartments of the water diffusion. Factor and principal component analysis may help to separate these compartments. The algorithm will estimate and extract accurate information of the signal variation inside the voxels, thus will estimate all the compartments which can be found in the multi-B diffusion MR acquisition. So in voxels, compartment-reflecting cells or gray matter, white matter, flow, and CSF can be extracted. Now let's see how BrainAnalyst handles this extraction. User has to select on the AW Workstation database the DWI sequence and click on the appropriate BrainAnalyst button. BrainAnalyst automatically loads the images and performs a brain extraction and a registration to a template, thus converting the images from the patient referential to the template referential. Once done, it performs PCA and effectuer analysis, extracts the compartments, and identifies high cells density areas in the volume. Thus, it creates a report for the end user and saves the compartment maps back into the AW database in a DICOM format. These maps are compartment maps of CSF, white matter, gray matter or cells, and flow, and can be further loaded in AW Volume Viewer, superimposed on FLAIR or T1 sequences. Now, angiogenesis estimation using combined perfusion and permeability. Another issue with brain tumors is contrast leakage, which avoids accurate estimation of the perfusion parameters without contrast leakage correction. We can perform a combined estimation of perfusion and permeability in Q2-star MR perfusion sequence using the BrainAnalyst patented algorithm, which corrects for the leakage, thus estimates the angiogenesis. To do so, the user in the AW database has to select the MR perfusion sequence and click on the appropriate BrainAnalyst button. In that case, PWI angiogenesis. BrainAnalyst loads the images, then performs a brain extraction, a motion correction and a registration to a template. It detects the best arterial input function, then corrects for contrast leakage if there is any, and estimates all the perfusion parameters CBV, CBF, MTT, Tmax, and so on. Then it estimates the permeability parameters such as FBV and KPS or K-trans, and using FBV it automatically detects the angiogenesis area in the volume. Then creates a report of the involved areas for the end user and saves back into the AW database all the perfusion and permeability maps in DICOM format. In AW database, the perfusion and permeability maps CBV, CBF, MTT, and FBV are gathered with the diffusion maps to be further loaded in the AW volume viewer. Now let's have a look at our practical case glioblastoma by selecting both MR sequences and BrainAnalyst maps and loading them into Volume Viewer. 4 informative maps are selected and superimposed on FLAIR and T1 gadolinium MR sequence and give us information about angiogenesis and tumoral cells involvement inside the brain tissue. As you can see, tumoral cells involvement in angiogenesis are of different locations. Now let's start something completely different, automated fabric tracking with BrainAnalyst. BrainAnalyst is able to compute connectomics, especially structural connectomics, using automated fabric tracking. It's a quite long process, requiring powerful computers. For now, only BrainAnalyst handles the fiber tracks, not the AW volume viewer. So let's see a normal case previously processed by BrainAnalyst. Just select the DTIMR sequence to the LW database and start BrainAnalyst. When done for the first time, BrainAnalyst will load the images, then will perform a brain extraction and a registration to template, then will estimate the DTI parameters and do the fiber tracking. 174 fiber bundles will automatically be extracted, analyzed and saved into the BrainAnalyst database. These bundles can be loaded and visualized into BrainAnalyst only for now. One of the convenient features of BrainAnalyst for the fiber tracking is the tagging cube. With this cube, user can interactively select and sculpt the fibers. Well, that's it for now. I hope this video was useful. Thanks for watching.